Hey everyone, so you're interested in learning a little bit more about how we use logarithms in solving real-life problems. Well, in this video, I'm going to show you 3 really cool applications of logarithms. This is the 3rd video in a 3-part series that looks at logarithms in mathematics. Now, if you have no idea what logarithms are, then I suggest click on the link up here to learn a little bit about logarithms. On the other hand, if you want to learn a little bit more about the properties, the laws of logarithms, then click on this other link up here. Otherwise, if you have a really good understanding of what logarithms are, the properties of logarithms, then keep watching this video. My name is Peter. Grab your calculator and let's get started. So the first application we're going to look at involves oranges. Oranges are a cheap source of vitamin C, and that vitamin C helps our bodies develop a strong immune system. Oranges also contain citric acid. The acidity of citric acid, or any solution for that matter, is determined by the hydrogen ion concentration. So in chemistry, we can use logarithms and the hydrogen ion concentration to figure out just how acidic is citric acid. In the next math problem, we're going to do exactly that. The first application says that the pH of a substance or a solution equals to negative log of the hydrogen ion concentration. The pH ranges from 0 to 14. A pH level of 7 is considered neutral, a level greater than 7 is basic, and a level less than 7 is acidic. So if you have ketchup with an approximate hydrogen concentration of 1.3 times 10 to the power negative 4, is ketchup acidic or is it basic? So the first thing we're going to do is we need to convert the first sentence of this word problem into a math equation. So the first sentence says that the pH of a substance equals to negative log of the hydrogen concentration. And that is going to look like this equation here. So all we're going to do now is we're going to substitute that symbol for hydrogen concentration with this number here, 1.3 times 10 to the power of negative 4. And we put that inside brackets. And then using our calculator, if you put all of this inside the calculator is going to give us a pH of 3.88. So we go back to the word problem and we look for what's the definition of acidic. It's a value less than 7. So 3.88 is less than 7. So that means that ketchup is actually acidic. Alright, so in the next application we're going to be looking at, it involves acoustics. So you're able to listen to your favorite song because sound travels through the air, it reaches your ear and it gets to your eardrum. One of the characteristics of sound is loudness. In our modern lives, there's so much noise around us. Traffic, constructions, there is a lot of sound. How do we determine if something is too loud? This is where we're going to be using logarithms to determine the level of loudness. If you're able to determine if something is too loud, then you're able to make public policy. So your local government might decide this level of noise is just unacceptable because it could be damaging to ears. And so in the next math problem, we're going to be looking at an application of exactly that, knowing the level of loudness and how it affects public policy. So the sound application says the loudness in decibels of a sound is defined as 10 log of I divided by I naught, where I is the intensity of the sound in watts per square meter and I naught is the intensity of a barely audible sound is equal to 10 to the power of negative 12 watts per square meter. Town regulations require the loudness of construction work not to exceed 100 decibels. Suppose a construction team is blasting rock for a highway. One explosion has an intensity of 1.65 times 10 to the power of negative 2 watts per meter squared. Is this explosion in violation of town regulations? So let's see how we would do this calculation using logarithms. So I have the formula here ready, and I'm setting it equal to a letter L, L for loudness. So I'm going to start off by just substituting the I in the numerator with 1.6 times 10 to the power of negative 2. And in the denominator, I have 10 to the power of negative 12. And then I'm going to simplify what's inside the parentheses by only subtracting the exponents because I'm dividing them. So I'm going to write the same thing outside the parentheses, 10 log parentheses 1.65 times 10 to the power of 10. So it's 10 because if you subtract negative 2 minus 12, you're going to get a positive 10. If you have difficulty remembering the rules for exponents, I suggest you watch the video that's up here in the link for more information. So after this, I'm going to put this entire expression here into the calculator, and I'm going to get 102.17 decibels. We go back to the math problem, and we're told that the town regulations require that loudness does not exceed 100 decibels. To answer the math problem, is this explosion in violation of town regulations? The answer is yes. Alright, here's the final really cool application of logarithms, and it involves prescription drugs. In the development of a drug by pharmaceutical companies, they have to figure out how much time it takes for half of the active drug to leave your blood system. This amount of time has a term, and it's called half-life. Half-life can vary from minutes, hours, weeks, depending on the drug. Sometimes it also varies depending on the gender of the patient, the age of the patient. But why would a medical doctor or even a pharmaceutical company, why would they want to know the half-life of a drug? One reason could be you do not want a patient taking a drug every so often while their blood system still has the active drug. What's going to end up happening is the patient might end up overdosing. So in the next math problem, we're going to take a look at an application of logarithms and drugs. In this third application, we're told that the equation that relates the half-life to the exponential decay is the following, this expression here, where n of t is the final amount of the drug, n naught is the initial amount of the drug, t is the amount of time that passes, and T, capital T, is the half-life. If someone initially ingests 1,500 milligrams of a drug and the half-life of that drug is 12 hours, when does the amount of drug in their body drop to 10% of the original dose? So we're going to start off by calculating the final amount of drug. 10% of 1,500 is just 150, and that's going to be equal to the initial dose, which was 1,500, times 1/2 to the power of lowercase t divided by 12 hours, which is the half-life. Now, after this, we're going to divide both sides by 1,500, and we're going to get 0.1 is equal to that exponential part. And then, since we want to have access to that exponential part, we need to introduce logarithms. So we're going to take the logarithm of the left side, so log of 0.1, and we're going to take the log of the right side, which is log of that exponential part. So this is a really important step because logarithms have a special property called the exponent property, which allows us to bring down that exponential part, that exponent. So this is going to be log of 0.1 is equal to t over 12 log of 0.5. So two important things. The exponent becomes the coefficient, and then I changed 1/2 to 0.5. So we're going to go ahead and divide both sides by log of 0.5 so that we're only left with t over 12. When you divide log of 0.1 and log of 0.5 and you cross multiply 12, your expression is going to be 3.32 which comes from dividing the two logs, and then we also need to multiply times 12. We're multiplying by 12 here because we have this 12 from the denominator we have to get rid of. So we have to multiply both sides by 12. When you multiply both sides by 12, your final answer is going to be 39.84 hours. And that's the amount of time it's going to take for that drug to drop to 10% of the original dose. There are so many more applications of logarithms in real life. I could not possibly fit them all in one video. If you found this video interesting, please consider liking the video and sharing this with your friends so that they can also understand the importance of logarithms. Until next time, see you guys soon.